Hey everybody, in today's video we'll learn on how to use map, filter and reduce using the Lambda expressions in both Python and Scala. We'll see the subtle differences between Python and Scala and the way in which Lambda expressions are used in both the languages. So with that being said, let me get started with writing the code in both Python and Scala. For Python, as usual, we'll be using Pycharm, and for Scala we'll be using Intellij. Okay. We'll create a new Python file in a Pycharm project that's already been created. So you can just create a Python project with whatever Python compiler or interpreter you have and keep it ready and start creating a new class. I'm just going to name it as like MapReduce. And in a similar way, you can create a new project in Intellij for Scala and create a new Scala file and place it here. As usual, you should go to the source method and then create a Scala class, choose an object, keep it the same name. Alright, we'll create an object, not a class, so that we can execute code. And as usual, extends app will make it a runnable code. So you see the play button established. Okay, so now we are done with the initial setup. We have our object ready in Scala and as well as a Python file ready. Okay, so let's quickly get started with writing some Python code. So what I'm going to do is like I'm going to just create a small list with say like 10 numbers and do some map, filter and reduce operations on the same. Okay, so we are going to do this on Python as well as in Scala, as simple as that. So we'll just see how different each language approaches the Lambda expressions and how well we can understand the same. For someone who's going to be comfortable in Scala, this should be useful. For someone who's comfortable in Python, this should also be useful so that they can interlearn between both of these. So once you're comfortable with one of these, you'll be able to do the other thing easily as well. So we've got a list created. So for this to run, we'll need a main method. Okay, so what we'll do is like just paste it here. So our main method is set here. So we'll try to do 3 basic operations on this list: a map operation, a filter operation, and a reduce operation. For the first step, we'll try to square each element present in this list and square it off, as simple as that. For that, we'll use the map function. So we'll name the list as squared list. Sorry with my spelling. Squared list equal to. So we'll try to map this list. Okay, so map of the list I'm going to put 2, and on what condition or on what operation that needs to be done on each element, we'll write a Lambda expression, as simple as that. So what's going to be written is nothing but just note the syntax and how it's going to differ with respect to Scala and Python. So we've named the expression as Lambda, and we are going to name the variable as say x, a colon, x star x, okay, and a comma. That's it. We've done our operation. So what we've done is like we've mapped this list with this Lambda expression. So take each element of this list and multiply it by its own value. Okay, so you can even multiply it by 2, etc. Okay, so let's do the squaring part for a start, and we'll try to print it out. So for printing it out, we'll need to ensure that it's a list object so that it's written in the output stream. So we'll just put it as squared list. We'll see if this runs. Perfect. So this is also running. This is running fine. Okay. So let's also print out the root list for a reference. We'll keep it as such. So we've got that. So now we can go to the filter method. For another example, we can just use any operation for this matter. Okay, so we'll just use the same variable name, and you can just use any variable. Okay, so it's going to multiply it by 3. It's going to print it out. Okay, so the values are multiplied by 3. Perfect. And if you wonder why this list is needed, this operation will return a mapped value. So if you try printing out this squared list as it is without the list appended to it, or without converting it to a list, you will only be getting a map object. Okay, so for it to be meaningfully displayed in the stream, you need to convert it to a list. So okay, see the map object. So that's the understanding. So we'll remove that for now. So now we've got 3 things printed out. So now you understand how Lambda works in Python, okay, so, or the map works in Python. We'll try to use the same list for doing a filter operation. So what we can do is like we'll think of a condition. Let's try to filter out only the even numbers. So the logic should be each element should be divided by 2 and the modulo should be 0. Okay, so x modulo 2 should return 0. So that's the condition we need to apply. Okay, and the problem here is like you're not going to apply it on each element, but you are going to filter out so that those elements are not going to be present at all. Okay, so here we mapped it to all elements so that all elements will be printed, but here we are only going to take elements that satisfy this condition. Okay, so that's the understanding. We'll just name it as filtered list. And we'll write our lambda expression again. So we are going to filter this list. Which list? My underscore list. Okay, so what we are going to do is like we are going to again apply a lambda expression. We'll copy the same lambda expression. Okay, so here the condition is going to be lambda x modulo 2 is equal to 0. As simple as that. So you've given a condition that needs to be applied, and we'll try to print out this list as well. Okay, so this is done. Let's run it. Yup, so the even numbers are filtered out. So the way of writing a lambda expression is pretty easy now. But there comes a catch when you are going to use 2 variables here, 2 or 3 variables here. So the understanding will be like how it's going to run into, say like you want to find out the sum of all of the elements, so you'll need to have some kind of a running variable. So for that we use something called as a reduce. Okay, so on a similar note on how we did map and filter, we'll try to use the reduce operation as well. And since we are going to do a sum of all the elements, okay, so we'll try to figure out what is going to be the sum of all of these elements. We'll try to find out the sum of this list. Okay, so we'll give it a name as sum list equal to reduce on this list. So this is how you should write it, just reduce and the list on which you're going to carry out the operation, so that the understanding would be nice. Okay, so you are going to reduce this list based on a condition. So we'll try to copy this again so that we have an understanding of what's happening. So the same thing is going to happen here, but reduce. Okay, so reduce needs to be imported. Previously reduce was part of the default package, but now it's part of the func tools package. Okay, so now that's being imported as well. Okay, so now what we are going to do is like we are going to take each variable and add them up together. Okay, so for that what we are going to do, it's like we are going to have 2 variables, x and y, okay, and make it kind of a running variable. So like how factorial works. Okay, so like you're going to do a recursive operation, recursive summation. So x comma y is equal to x plus y. So how this is going to work is like 1 plus 2, which goes to 3. Okay, so 3, and this will be again we summed up with 3, so 3 plus 3, which is 6, 6 plus 4. So this operation will be summed up with the x value. Okay, so hope you understand that. So now let's see how this is going to run. And since this is a list by default, you can just print it out. You don't need to convert it to a list since we are already reducing it. You're not doing any map. Perfect. That's the sum. 3, 6, 10, 15, 21, 28, 36, 45, 55. So hope the understanding is great. So if you want to do a recursive operation like a summation or a multiplication, you can use reduce. Say like when you do a word count, like you have 100 words, and you're going to find how the MapReduce algorithm works is like if there's going to be 100 words, each of the words will be mapped with 1. Okay, so A comma 1, B comma 1, C comma 1, and after that each of them will be reduced using the same logic. So each key that's common, say like if A is going to have multiple repetitions, all of it will be reduced and the sum will be added up like this. So that's the understanding with reduce. So now let's quickly do the same operations in Scala. Okay, so let's quickly open up Intellij. We've already set up the project, we've created the object. We'll try to work on the object. Okay, so we'll try to generate a list here. Well, nums list, we'll try to generate it rather than writing it. That's the advantage of functional programming, right? Okay, so this is how things work here. So now if you're going to print it out, so this is the beauty of Scala, you can write code like this. Even here you can define a list and assign or initialize the values like 1, 2, 3, 4, 5, 6, but here you can use these kind of functions. But for using this function, you'll either need to terminate this using the semicolon. The understanding is it's going to interpret as if you're defining a list and you're going to write some code even in the next line. Okay, so the understanding is you need to terminate it using the semicolon if you're going to write the code in the next line, or leave a gap or leave a line in between the next command, next executable line of code. Okay, so we'll leave a line as a space and take it forward. So this is one thing that you'll need to learn as well. So the same functionality can be achieved using like creating a list like this, list of 1, 2, blah blah blah. Okay, so I didn't want to do that, so you can even use that approach as well. Okay, we'll try to print out the list. Now it's printed fine. Now we'll go ahead and do the same map, filter and reduce operations. Okay, we'll see the difference. We'll try to stack both the Pycharm and Intellij windows side by side and observe the differences between the two. For now, let's go ahead and quickly implement the map function. So what I'm going to do is, like, again I'm going to use a similar naming convention. Squared list is equal to, here observe that you're not writing the function here, you're going to write the object that you're going to play with. Okay, so you're going to apply the map function on this list. In Python it was the reverse, you wrote the function that you're going to apply, but here you're going to put the collection or the object that you're going to apply the functionality on and use map. Okay, so now we are going to apply some operation on this list. So the operation is pretty easy here. Here you do not need to write explicitly as lambda, this equal to greater than symbol signifies a lambda expression. So num is equal to num star num. So as simple as that, pretty easy here. Okay, so there you have observed like a colon is absent and a lambda keyword is absent. That's the difference. If we copy the code from here and try to copy and paste it into a small observation. So here the thing that is absent is the lambda keyword and the colon, except that all the other things are fine. If you just want to keep this same, that's it. Instead of the colon, just use the lambda expression as part of Scala and remove the lambda keyword, and you're doing the reverse operation here. You're putting the list here and the map here, so it's a bit reversed. All the words or all the keywords are switched and the functionality is achieved. That's the syntax point of view if you're still getting confused. Okay, so now we'll try to print out the squared list. As simple as that. So we'll quickly go ahead and do the filter. I think now most of you all would have had the hang of it. So we'll try to again do the even list. We'll try to copy the even logic from Python. So we'll see how it goes here. And so here how these things are going to work out. So we'll try to have something like filtered list. Okay, so we'll have the same name here. So see here the operation is at the start, but here we need the list. So here the name of the list is nums list. So dot filter. So this is the advantage of using Pycharm. You get all of these IntelliSense display rather than using a notebook like Jupyter. So here the condition that's going to be applied is like similar to this. You're going to write x lambda x modulo 2 is equal to 0. Okay, as simple as that. So the list has come here, the filter has come here, the lambda has come here. Remove this and that's about it. Okay, so we'll try to print this as well. And we'll write the reduce part as well so that we see all the outputs together. We'll try to get the code from the Python. So that's it. We'll use the same name, val sum list. Again, we are going to use the same logic. Reduce. So this is the list. So here it's the nums list. Put the list here. On that, apply the reduce functionality and apply your lambda expression. The lambda expression is going to be the summation. So what we are going to do is like x comma y. Sorry, x comma y. Since we are dealing with brackets or anything explicitly called as lambda is not defined, so we need to enclose it within brackets. Okay, so even here if you find there is always a bracket, okay, but it's forgotten or it's not used since if you're only using a single variable, but for a couple of variables or for a summation you need to use a parentheses. Simple as that. The same logic here, x comma y, x plus y, that's about it. We go to println. We'll see how it goes. Perfect. So all of these things are printed. So we've seen the basics like of map, filter, and reduce, which are going to be like the key constructs when you're using Apache Spark or any language which you're going to use along with the functional aspects of Python and Scala. So hope you understood the differences between both of these. Um, if someone who's familiar with Python, he can quickly switch over to Scala. If he's familiar with Scala, he can quickly switch over to Python. So these things only cause the most confusion. All of the other things are mostly similar, except that you have the conditional arguments and the spaces or the indentations that cause a little bit of a headache with Python, but all of those are not um, pertaining to Scala. So that's what I wanted to cover today, the functional programming aspects in Python and Scala and the differences between them. There's a small amount of difference between the usage. So I just wanted to cover the subtleness in which both of those differ. Okay. So hope you found the video useful. Please continue to like my videos and subscribe to my channel. Thanks once again. Signing off, Ashwin.